Okay, today's video is going to be about the 30, 60, 90 special right triangle, the relationships that happen in that triangle, and then how we use those relationships to find missing side lengths. So remember, we get our 30, 60, 90 triangle from an equilateral triangle where all of the angles are 60 and all of the sides are 8. We took our equilateral triangle and we drew in a median from vertex to midpoint. And then that split the bottom part into 4 and 4. So then what we did is we found the length of this height. This gave us our right triangle here, 60 degrees, and then half of 60 makes this angle right here 30. So now we have all of our angles. What I like to do is redraw the triangle. So 8, 60 degrees, 30 degrees, and 90. And then that makes this portion down here 4. Then we used Pythagorean theorem to find our missing piece here, our height. So we had 4 squared plus x squared equals 8 squared. 4 squared is 16. 8 squared is 64. We subtract 16 and we get x squared equals 48. Then we had to take the square root on both sides. So I get x equals the square root of 48. Factors of 48, including a perfect square, are 16 and 3. So x is equal to 4 root 3. So the height was 4 root 3. So we found that this pattern happened where the shortest side was 4, the height was 4 root 3, and the hypotenuse was 8, twice the length of the smallest side, which gave us this pattern right here. The smallest side is always across the smallest angle. The largest side's always across the largest angle. And then in the middle here, we have our 60 degrees opposite our x root 3. So the pattern always follows that the smallest side is x. It's whatever that smallest side is. So if it was 10, let's say it was 10, then the hypotenuse would be twice the length of that, which is 20, because remember, it came from the equilateral triangle. So 10 and 10, that would have been 20. Then when we would have done Pythagorean theorem, we would have gotten 10 root 3. So let me erase this little part here. So that's our pattern that we're going to follow. We're going to use that pattern to work some examples where different numbers are given for different side lengths. So for our first example, I like to fill in the missing angles if I have any. So 30 degrees here. We really like it when the information across from the 30 is given to us. That's pretty much the easiest way to solve the problem. So if the side opposite the 30 is 11, I automatically know that the hypotenuse, which is x, is twice. So x is actually 2 times 11, which is 22. And then y follows the pattern of the smallest side 11 times the square root of 3. So I get 11 root 3. So x is 22, y is 11 root 3. And it just follows the pattern that we were given. Okay, for the next one, I'm going to fill in my information. I have the 60 degree side, the side opposite the 60 degree. It's a little bit harder, but it's nice because the information given has a square root of 3. So I know going forwards from the smallest side to the middle side, I multiply by the square root of 3. So to go backwards, I'm going to divide by the square root of 3. So I'm solving for x here. I'm going backwards. And these square root of 3 over square root of 3, that's just 1. So I get 13. So I have x equals to 13. And since I know that the smallest side is 13, I know that the hypotenuse is twice that. So y is equal to 2 times 13. Which is 26. So I get y equals 26. The next one gets a little bit harder. We are given the information across from the 30, but this time we've got a radical 3 in our information. Not anything we can't handle, but we're going to have to add a little bit to it. So to find the hypotenuse, I tend to find the hypotenuse first. It's twice the length, so 2 times 5 root 3. 2 times 5 is 10, so y is 10 root 3. To find x, I take the smallest side, so 5 root 3, and I multiply that smallest side times the square root of 3. So now I have 5 times the square root of 3 times the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3, so I get 15. So I have y equals 10 root 3, and x is equal to 15. So the next one down here, number 4, we are given the information across from the hypotenuse, which is different. So I'm going to start by finding the information across from the 30 because that's how they're related. The hypotenuse and the smallest side is half. So I'm going to solve for y, and it's going to be the hypotenuse, 4 root 3, divided by 2. Remember, it came from that equilateral triangle. It's half of it. So 4 divided by 2 is 2, so I get 2 root 3. And then to find x, the side across from the 60, I'm going to take that smallest side, 2 root 3, and I'm going to multiply by the square root of 3. So I get 2 times the square root of 9, which is 2 times 3, so that's 6. So I get y equals 2 root 3, x equals 6. And our last one here that I'm going to do, we are given the information across from the 60, but this time it is not in the form of something radical 3. It's just a whole number. So in order to solve for x, which is the smallest side across from the 30, I'm going to have to divide this side across from the 60 by the square root of 3. So I'm going to take 12 and divide by the square root of 3. Now, this would be an okay answer, but you wouldn't get full credit. You've got to rationalize this answer. So that means get rid of the radical in the denominator by multiplying by the square root of 3 over the square root of 3. So in the top, you get 12 square root 3, and in the bottom, the square root of 3 times the square root of 3 is just 3. Now this 12 and 3 simplifies to 4, so I get 4 root 3. So this smallest side over here is 4 root 3. To find y, I know that my smallest side, 4 root 3, I can take that and just multiply by 2. So I get 2 times 4 root 3, which gives me 8 root 3. So here we have x is 4 root 3, y is 8 root 3. There's our two answers.